All right, so let's talk through question number 8. So it says, for each of the following tables, explain whether or not the quantities are related by a constant rate of change. That is, whether the changes in the quantities are proportional. So remember, the easiest way to show that proportionality is using the ratios. But to do a constant rate of change, we first need to find the changes in quantities. So really, we need to find all of these changes here. So just as a reminder, if I want to do this, you have to be careful with negatives. To find the change from -4 to -1.6, I actually want to do -1.6 minus a -4. All right, because when you find the change in a value, you want to find the change or the value that you went to minus the value you went from. That's what we decided, or that's what we found out was the way that we always find that change. And so when you do that change, you're actually going to get 2.4. So this right here is a positive 2.4, which makes sense because our input increased, right? It was -4 and now it's only -1.6. You do the same thing for the second one, so 3.6 minus a -1.6 is going to be 5.2. So here I get 5.2. We're going to do the same thing on the other side, so just to finish the writing, it would be -26.72 minus a -42.8. When we do that, we get 16.08. Again, it makes sense that this is a positive number because our values went, or our output went up. That number is less negative. And then finally, 9.12 minus a -26.72, and you're going to get 35.84. So this is a positive 35.84. So we found our changes, but then we still have to find out, are those changes proportional? Right? That's how we find a constant rate of change. So to do that here, we want to find the ratio of the change in output to the change in input. And we need that for the corresponding. So for the first set of changes, we'd say, is that ratio of 16.08 divided by 2.4, is that the same as 35.84 over 5.2? Right, that's the question we're trying to answer. If I do 16.08 divided by 2.4 in my calculator, I'm going to get 6.7. If I do the second ratio, I will get somewhere around 6.89. And so we're going to find out, no, those quantities are not proportional, those changes, and so therefore there is no constant rate of change. So that is the first table. So now we can do the same thing with the second table, right? Same exact idea. So I would find my changes from -6 to -3.1, right? So -3.1 minus a -6, I'm going to get 2.9. Again, it makes sense that my number is positive because that output is, or that input is increasing. Then 2.6 minus a -3.1, we're going to get 5.7. So this change here is a positive 5.7. And I probably should have done this on my left table, but you can always label those changes to be explicit about those. So I may as well go back my green pen and do that. Right, I'm going to need to do the same thing with my outputs. So to find my change in output, 24.09 minus a 35.4. In that case, I get a -11.31. That makes sense. My output has actually gone down. And so it should make sense that I get a negative change in output. And then I do 1.86 minus 24.09. I'm going to get -22.23. Again, it makes sense that my value is negative, because that, because that output went down. Let me get rid of that. Oops, I guess I'll just get rid of all that. So -22.23. Then the last thing I need to do is again say, are those ratios of the changes constant? So in this case, is -11.31 divided by 2.9, is that equal to -22.23 over 5.7? When I do this in my calculator, I get -3.9. When I do my second ratio, I also get -3.9. So the answer is yes, there is a constant rate of change, and the value is that -3.9. That's the other advantage of doing the ratios, is when you find that ratio is constant, that value is the value of my constant rate of change.